Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Today we will talk about a new subject which is in chapter 15.1, partial differential equations, or as abbreviation PDE. And this one we will define the partial differential equations. So in that case here we will consider this general form, where is here a constant times derivative of a function u. This u is function of two variables x and y. So it is partial derivative 2 times with respect to x times a constant, plus another one but with respect to xy, then plus constant times another one with respect to y. So this is second derivative, and then plus anything else like a function of the u itself, function of x, function of y, function of derivative, first derivative with respect to y, first derivative with respect to x, and this is called the partial differential equations, or PDE. This we will consider in 3 parts. So how do you solve this one? But before we solve it, we would like to have a names. This name depends on this value, which is like determinant when we solve a quadratic equations. So this determinant could be positive, could be negative, could be 0. If this one is 0, it means we call it parabolic equations. If it is positive, we call it hyperbolic equations. But if it is negative, we call it elliptic equation. Therefore, we will study 3 cases in chapter 15.1 parabolic equations. We will study in chapter 15.2 hyperbolic equation and 15.3 elliptic equations. Okay, so now today we will start with parabolic equations. And we'll start with very simple parabolic equation. Here it is, very simple one, which looks like this one here in general. If you compare this with this one, you will see A is 1 and B is 0 and C is 0. Here there is nothing here. So here if you calculate this B0, so B squared 0, and this one is 0, it means 0, it means this is really parabolic equations. So anyway, so here we will take, so this can be written like this as well, put it both sides. So now this one again, another one here, but just is the same as before. If you calculate it this way, if you have different one, A0, B0, C0, it means again parabolic equations. So when we study this parabolic equation, we should have 2 conditions. One of them called initial conditions, another one boundary conditions. So what is the difference between both? Just let's take the very simple parabolic equation, ut equal uxx, where x between 1 and 3. But really in general this x between A and between B. So between 2 values, and t here, because it's the time here between greater than or equal 0. So in this case here you can see we don't have x and y, we have t and x. So this is different because t for the time and x is another variable. So what about the initial condition? Initial condition means when we start with the time, t equals 0. If you substitute here t equals 0, it means no t. It is only u become function of x, so we'll call it f of x. So this is when t equals 0. And that one called initial conditions. And similarly, but now we will take x is at the beginning and x at the end. So here we will come to boundary condition. What is it here? If you put this as 0, or as we said before, it is A given something, or B or 1, it is given something. In this case, we are taking it equal to 0. So this is t greater than 0. In that case here, we will have this called boundary conditions. And really, if we want to say this is something, if we have something like this is initial conditions, and if we take x here, those boundary condition, that one boundary conditions. So here it means t here is equal A, and t here is equal B. And here, in that case here, x equals 0. So this is really what we have to do in that case, and we will go to next slide to see further applications. So now here, if you noted this one, like just what we did with ODEs, okay, so here we will take, because we talked before, like, remember that yxi, we approximated by y, we put it sub I. Here now, similarly, we have u, when we put it sub ij, it means not equal this, it is approximation, so this should be approximations. Because this is here we at xi, and here is ti. Okay, what is xi? Xi like before, so we'll put here xi, it will be in the future here. So xi equal like before, I times h, so the step length is h, but here we put now, this one is equal ti equal, and this is so ti or tj we will call it, which is equal, we call case, the step length now is k times g. So this one here really, so this is here the equations, and that's what we'd like to solve. Just like before, but now we have two variables. That's the only difference. Okay, now we use some approximation, numerical differentiation, which we have learned before. So in that case here, like here derivative, first derivative, but is with respect to t. So it means this partial derivative with respect to t. What we have to do, now we would like to use forward partial differentiation. This forward can be written like, so we put here sub t just to indicate that we are going to do this with respect to t, which mean I here on the left hand side. Sorry, it should be j, t is j, I for x and j for t. So in that case here, that one left hand side. What about right hand side? Right hand side, the second derivative, again we use numerical approximation or differentiation. This is approximated like this. And really this should be all of them here is square, delta x square, not delta square x. And this one here will give me the approximation. Well, how to calculate this? Now the equation now changed by this. Okay, again here, this square is not here, it should be here. So now we have the equation, that's also, we have to do this. Instead of writing delta t, we write it k, just for simplicity. And let me do it again here. So we call it k, this is delta t, or delta x equal h like as before. Just for simplicity, so this equation becomes like this. So now we know all of this. Now this is the equation which we can use and easily. For simplicity, if you multiply by x, we would like to write ratio k over h squared. So the equation is like this. And now we would like to use this equation. As we said before, here is between x0 to x, between x0 and xn, or a and b, and this is t here, starts from 0. So next step, we will see how to do it. So what we have wrote before, this is the difference equations, and we know the meaning of this one here. Just we have to replace what is it here. Like this one now, delta this one, what is it equal? It's not t plus, no, this is delta t, it means, no, it is not like this, it's not delta t. The delta t is not defined, there is nothing like this. So here, this is delta t, remain delta t. Because this notation, it means make this with respect to t. So when you do it with respect to t, it means j plus 1 and here j, which we call it forward difference equations. And the right hand side is the central difference, but with respect to x. X means i's. When you do this one, you calculate it, you will find this is the answer. So this is if you put f, but now instead of f, write u. So here is the answer. I plus 1 minus 2 ui plus I minus 1. J remain unchanged. And the left hand side also forward difference with respect to j. And here we have the equation now. Just we rearrange it like this, take this one here, right hand side, so it will be that case here. So it will be written u, so j plus 1, which means the time is j plus 1. The right hand side, there is j here, j here, j here. So we replace like for j, when we substitute here in this equation, we'll get the answer for j plus 1. And we usually start with j equals 0, then we get this u at 1. Then substitute for j equal 1, we get at 2. Substitute for and get at 3, and so on. In that case, we will know approximate answer wherever we like. Here just we are repeating again, xi equal I times h, like before, like ODEs, where I between start at a until n. How do you find n? Like before, b minus a divided by n. And k here, k, because this may goes to infinity, k is the time, there is no end, so we say just t greater than or equal 1, so k equal, so here what is k? Yes, this is the ratio for this one. But j equals 0, 1, 2, and continue in that case, and we will see some application in next. Okay, so now we start with the first example. Okay, now. So we'd like to solve one of the PDEs. Just we will consider solving parabolic equations with step length equal 0.2 and r equal this. It means if we use the ratio, we will find something. And here the equation, just think about it, and we'll come to next slide. So here, because this is 0, so it's function of x, we put it like this, when t equals 0. This is the initial conditions. Now a boundary conditions, because we'd like to say x between 0 and 1, we have to say the value at x equals 0, we took it 0 for all value of t, and u at 0.1 for all values of 1, and in that case t greater than 0. So in this case here, we know all these values, initial value conditions, and we know the boundary condition, all these values. We will solve it in next slide. Thank you very much.